Hello everybody. Today we will learn how to define and classify matter. As you know, matter, everything that is around us it comes under the classification of matter. Before we go any further, you also must understand how to define chemistry. Do you know how to define chemistry? You are in chemistry class. Chemistry is the study of matter. So everything that is around us, it comes under the definition of matter, and the study of that matter is called chemistry. So it is a big job that you're going to do this year. So let's go ahead and get started. By definition, matter is everything that has mass and that takes space. So of course, everything that exists in nature is at least taking a space to exist, if nothing else, and has a mass. So everything that exists comes under the definition of matter. So the matter that we see around us could be classified in two main categories. As you see, there are two main categories. One is called pure substance and one is called mixture. All right, pure substance and mixture. So let's talk about pure substance a little bit. Pure substance means pure, everything that in which all the atoms, all the particles are exactly the same. So whatever the mass, the color, the charge, anything that you have is going to be the same. So that is what means pure. It needs to be uniform. It's you're not it's not changed from here to here. It has this uniform composition. So that is pure. So when we talk about something that is pure, like water, a glass of water, no matter where you drink water, it is going to be H2O. Okay, that's one example of pure substance. But there is another example of pure substance that is called element. An element means that all of the atoms are exactly the same and you cannot break it any further down. So element, um, we know different elements. You know carbon, you know hydrogen, you know oxygen, you know gold, you probably know silver, you know about iron. So what element is that all atoms of any element are going to be the same no matter where you get it in the world. So all the atoms of carbon, if for example they are like this, then no matter where you go, this is how the atom of carbon will be. And all the atoms of maybe let's say hydrogen, if this is how it is, then this is how it will be no matter where you take in the world. They will all be the same mass, same shape, same size, same composition. But do you see that the elements of carbon are different than the elements of hydrogen? So different elements have different type of atoms, but all atoms within one element are going to be the same. So that's what makes it pure. If I mix the two together, if I mix this and let's say for example this together, in one place, no, this is not pure because it has a mixture of two different things. So if I want to say pure, then this is what the pure is, where they are exactly the same. All right, so I hope you understand what an element is, in which all atoms are exactly the same. Now, the second type of pure substance is called compound, and I gave you an example of compound right here, where two or more than two elements chemically combine. So they chemically combine to make a new substance. So when elements chemically combine to make a new substance, if they change their properties, they change everything, that the way they behave, their chemical behavior has changed, and they have produced a whole new product. So that is called compound. So I gave you an example of compound right here, which I'm going to write again, H2O. It is a compound. It is made from the element of what? Element of hydrogen and element of oxygen. But once they're combined, the properties of water do not match with the properties of hydrogen or the properties of oxygen. For example, hydrogen itself and oxygen itself are gases, whereas water is not a gas. It is liquid, at room temperature. And oxygen helps the fire, it kind of adds it or below it, whereas water puts the fire off. So their properties are going to be different because they have chemically combined to produce a new substance. All right, so let's go back and see what we learned so far. We started with matter. Anything that takes space and has a volume comes under the definition of matter. Now, matter could be pure substance or mixture. What we learned about pure substance is that there are two kinds of pure substances. Okay, there are two kinds of pure substances. One is element and one is compound. So this is what the pure substance is. Let's talk about the other side of the matter, which is mixture. Uh, Means you have, it could be the mixture of elements, it could be the mixture of compounds. Okay, so if we have the mixture of elements, all you're doing is you're taking the two elements and you just shake them up. That's the mixture of two elements. Okay, for a compound, I can have water, okay, and I can have salt. I'm not chemically combining them. I just take a spoon of salt and dissolve it in water, okay, to make a solution. So it is salt plus water. How do I know it is not a compound? Because when I drink it or taste it, I do taste water and I do taste salt. That means they have not chemically combined to produce a new substance, just like a compound. In compound, when element combined, they produced a new substance. Here, it is not a new substance. It is still water. It is still salt. If I like, I can evaporate the water and get the salt back. So, keep it simple. Mixture is something that is not a chemical combination. It is just a physically, you just shake them together. That makes it a mixture. So it is two or more pure substances, could be element, could be compound, that keep their individual properties. So it's gonna stay, water is gonna stay as water, salt will stay as salt. There are two types of mixtures, homogeneous mixture and heterogeneous mixture. Homogeneous mixture is like a solution. I gave you an idea already, like salt and water. When you drink that salt and water, no matter which sip you take, if you have stirred it, it will taste the same no matter which sip you take. For example, when you dissolve sugar in the coffee, every sip of the coffee is equally sweet. That means that the parts are blended together, okay, and they have a constant composition. That no matter if this is the coffee you're drinking, then no matter it is the first sip that you take or the last sip you take, it's going to equally sweet. So that is a homogeneous mixture, and solution is an example of homogeneous mixture. So some examples given here are lemonade, sweet tea. Steel is the mixture of two different elements. It's a solid. So if you mix iron and carbon together, that's what the steel is. So make sure you understand that the steel is not a compound. Steel is a mixture. Okay, and steel is a homogeneous mixture. The other type is called heterogeneous mixture. Okay, I'm going to just hold on one second. It's too much mess here and I don't like it. So I'm gonna get rid of it. Okay, let me just clean the page because it's too much. Okay, so what I'm explaining is that for mixture, there is homogeneous mixture and there's heterogeneous mixture. Heterogeneous mixture is where yes, you did shake them together, you did not chemically combine them, but they did not mix very well. For example, sand and water. Sand will stay as sand, water will stay as water, oil and water. Yes, you can mix them, you shake them together like, the salad dressing. So if you let it sit, you see all the oil that's in there, and some of the ingredients of salad dressing are very well mixed up, but there are others which are not very well, equally combined. So the composition is inconsistent. For example, the pizza. When you take the pizza, you can taste everything that's in there, but everything is sitting out separately. If I don't like mushrooms, I can take them out, hand pick them, or you can just take a mixture of salt and pepper. So when I look at it, I see the salt and I see the pepper. So salad or pizza or soil chocolate chip cookie, oil and water. These are all examples of heterogeneous mixture because there is consistency in their composition, and they can be different. You know, the oil and water combination that you probably make is different than what I make. The soil of Virginia could have different composition than the soil of Pennsylvania. So there is an inconsistency in their make, whereas compound was not inconsistent. If water is 2 to 1 ratio of hydrogen to oxygen, then it will be 2 to 1 ratio of hydrogen to oxygen no matter where you go in the world. It will be the same composition. So please do understand there is a difference between compound and a mixture. So in summary, we learned about the matter classification of matter. You need to know the definition of matter. You need to know the two types of matter, pure substance and mixture. And then pure substance is further divided into element and compound, and mixture is divided into homogeneous and heterogeneous. And if you do understand it, you need to complete the bottom half of the page and show it to me in the class. How do you do this? So let's once you complete it, you can watch the other video that is on significant figures. Thank you very much. Bye-bye.